X36D, the GNSS INS high-precision combined navigation system, is based on the self-developed chips by Bynav technology. Automotive design is incorporated in every part of it. It contains a high-precision IMU and supports full constellations, multi-frequencies, and dual antenna orientation. It has the deeply coupled combined navigation algorithm built inside. With a rich set of interfaces, it can effectively deal with complex applications and scenarios. The X36D is a compact box with multiple interfaces. There is a main interface and two RF interfaces on the front. The interface ANT1 and ANT2, respectively, use FACRA-C and FACRA-D connectors. The main interface includes power supply and RS-232 serial ports, automotive Ethernet, CAN, FD, PPS, etc. The DC power supply voltage should be between 9 to 32 volts. A stable 12 volts DC power supply is recommended. The X36D is equipped with two RS-232 serial ports. The highest supported baud rate is 921600. Currently, only COM1 can be used to send commands to configure the box. COM2 is a reserved serial port for internal use. If there are higher data transmission requirements, or if GPTP, the time synchronization function, is needed, please adopt the automotive Ethernet. Its four ports are 1111, 2222, 3333, and 4444. There is no functional difference between the ports. All support data transmission via TCP or UDP protocols, simultaneously or separately. The CAN-FD interface is compatible with CAN-frame input, and the PPS interface can be used for PPS time synchronization. In addition to the aforementioned X36D main cable and RF connection lines, you may also need to prepare a 12 volts 5 amperes power adapter and a socket, as well as a laptop with a Windows operating system. To facilitate connection with the computer via the serial port, RS-232 to USB converter is also needed. When using high baud rates such as 921600 for communication, please ensure that the cable also supports it. If you choose to connect with the computer via the Ethernet port, you need to prepare an Ethernet cable and an automotive Ethernet to industrial Ethernet converter. Welcome to contact us for purchase of the converter. Also, please make sure you can access to our TK correction service, for example a valid trip account. The devices that need to be installed include the X36D and a high-precision GNSS antenna. Taking the installation on a sedan as an example, the box should be rigidly connected to the vehicle. It is recommended to fix the box with screws. If the on-site conditions are limited, it can also be fixed with 3M tape. It is recommended to install the X36D with its Y-axis pointing to the vehicle's driving direction. The X-axis points to the right side of the vehicle. The Z-axis points upwards. The high-precision GNSS antenna, commonly known as the mushroom antenna, can be fixed on the roof of the car with a magnetic base. Here, we choose to install them along the vehicle's traveling direction. The distance between the antennas is recommended to be greater than 1 meter. After the installation is finished, connect the antenna to the X36D with an RF cable. The ANT1 interface of the X36D is connected to the antenna at the rear of the car via a FACRA-C connector. ANT2 interface is connected to the antenna at the front of the vehicle via a FACRA-D connector. Then insert the main connection cable into the main interface of the X36D. Use an RS-232 to USB converter to connect the laptop and X36D, or an industrial Ethernet cable and an Ethernet converter to do so. Then power the X36D with a power adapter. Download by Connect, the upper computer software, from the official website of Bynav Technology. No installation is required after downloading and extraction. You can directly double-click to open it. Click the connection button to open the connecting setting module. The default serial port baud rate is 115200. After opening the serial port, you can try sending commands. If the box does not respond, you can change the serial port and retry. If using Ethernet communication, you should know the default configuration of X36D's Ethernet as shown in the video. Then use any default port number, such as 2222. Enter the command and click the Send button when the correct serial port is in use. please enter and send another 6 commands to enable the output of some required messages. In the RTCM config module of the upper computer software, enter the relevant information of the trip service. These information can generally be found on the service provider's website. If the antenna on the roof of the car is in an open environment at this time, a fixed solution can be obtained quickly. Next is the measuring and setting of RBV and the antenna lever arms. RBV is used to describe the relationship between the IMU body frame and the vehicle frame. If the X36D is installed as recommended earlier, that is, with the Y-axis pointing to the vehicle's driving direction, the X-axis pointing to the right side of the vehicle, the Z-axis pointing upwards, you can directly send the command in the video to configure RBV. If it is not installed as recommended, then the 3 values of RBV may not be zeros. You can get the correct RBV values in ByOffset by choosing how you actually installed X36D. Antenna lever arms are characterized by the 3-dimensional distance from the IMU center of navigation to the antenna phase center. Measure using tools such as a tape measure as shown in the diagram and obtain the 3 measured values of X, Y, and Z. Then return to the main interface of the upper computer software. Enter the command in the input box and send it. The example in the figure is the configuration of the ANT1 lever arm. The above operation can also be done using the inertial navigation module in the upper computer software. Similarly, measure and configure the values of ANT2 lever arm. Finally, send the commands saveconfig and reboot to save the lever arm configuration and restart the X36D. After the X36D restarts, if correction data input is still maintained and the antenna is in an open space, in the lower right corner of the upper computer software, the first 2 indicator lights will turn green. The third indicator light will turn yellow. That is, the combined navigation has entered the mode of course alignment. If you plan to connect wheel speed later, you also need to complete the measurement and configuration of the NHC and DMI lever arms. The NHC lever arm is characterized by the 3-dimensional distance from the center of the rear wheel axle to the IMU center of navigation. Insert the measured NHC lever arm values to the command and send it to complete the configuration. The DMI lever arm is characterized by the 3-dimensional distance from the geometric center of the wheel to the IMU center of navigation. In the inertial navigation module, we can enter the NHC lever arm measured in the previous step, the wheelbase and axle track to calculate and set up the DMI lever arms. Choose an open straight road that you can turn around the car. It is recommended that the length is not less than 1 kilometer. Drive back and forth on the road at a speed of not less than 18 kilometers per hour. Keep driving until the third indicator light in the lower right corner of the upper computer software turns green. In the command input box of the upper computer software, enter and send the command in Calibrate RBV new. Keep the vehicle driving the same way. Pay attention to the source status field in the install status message. When it changes to calibrated, it means that the calibration is complete. Record the offset values of the X, Y, and Z axes at this time. Then send the commands saveconfig and reboot to save the calibration results and put it into effect. After the restart is complete, send the command log instaconfig once. Compare the RBV offset values in the feedback with those recorded in the previous step. It works if both of them are inconsistent. Otherwise, you have to manually set up the RBV with the commands in the previous step. Now, the X36D test platform is established.